for geometry and physics. This is, for this year, the first De La Pietra lectures. As you probably know, the De La Pietra families, of which we have the pleasure to have among us Vincent De La Pietra and Barbara Amundsen. They are great benefactors to the university, and in particular, they've been supporting activities at the Simon Center for the last many, many years. There they are here. Here they are. Vincent and Barbara. Thank you. Anyway, so they allow us to be, they are endorsing these lectures. The good thing about it is that we have the capacity of inviting extremely prestigious speakers, like Persi Diaconis today, and they will stay for a few days. So tomorrow, there will be a talk for high school students. Even adults are allowed, no problem. And then on Thursday, he will give a technical talk. So those who really want to get into more the mathematics of what he does, is again open access. So those who really want to come, please join us. Now, I think that Persi doesn't need any introduction, so he also has the philosophy that less is more. So I'm just going to be reading what is written in his webpage in Stanford. He's the Mary Sansary Professor of Statistics and Professor of Mathematics, and he's a mathematician and a statistician working in probability, combinatorics, and group theory with a focus on applications to statistics and scientific computing. A specialist in rates of convergence of Markov chains. He's currently interested in trying to adapt the many mathematical developments to say something useful to practitioners in large real-world simulations. As you know, in engineering, in physics, mathematics, climatology, and so on, large-scale simulations are almost the word of the day. So it's really nice that Persi is bringing his expertise to give some advice on how to interpret this particular data. Persi, please. Thank you.
Now, I think my mic is on and people can hear me. That's good. Hi. Well, as Louis said, I'm in some order. I'm a statistician. I'm a probabilist, a mathematician, and a magician. I'll never live that down, and don't want to. And I want to talk to you today about something that all of you know a lot about, which is coincidences. And so let's begin by admitting that weird things happen. If any one of you has had things happen that seem surprising and inexplicable, and what does somebody like me, who's a kind of arch skeptic, have to say about all that? So that's what this talk is about today. And I'm new to this system, but have every hope that it'll work great. Just to show that we're mainstream, here's the front cover of the New York Times Magazine. This reporter was trying to understand and come to terms with the following fact, which was that in a 4-month period, 10 scientists in different parts of the US and some in the UK were found dead, or some of them murdered, and in mysterious ways. And it turned out that all of them were working on bioterrorism. And people noticed this and were speculating, was one of the forces that be trying to quiet it down, or could it just have been an accident? And she was very moved by that and tried to explore it and look at the case histories. And that's the kind of thing where if a lot of things happen in a short period of time that have some structure, we worry in it and it gets to us. So if you're interested in more careful lists of coincidences, there's something called the Coincidence Collection website. There's a marvelous collection at Cambridge, the Cambridge Coincidence Collection, and it's interesting because it's people vote on them or comment on them and try to verify them, and so it's 5,000 to 10,000 coincidences. If you're interested in reading something and haven't read it yet, Salman Rushdie's Midnight's Children is a marvelous account of the magic of coincidences. This talk I'm giving you is joint work with Susan Holmes and Fred Mosteller, and we got mentioned on the front page of the New York Times as, professors study coincidences, and I got to tell you, you really get a lot of funny mail and, when that happens. So I've got thousands of them trying to follow them. Just so that to start someplace, so we might know what we're talking about or start someplace, what is a definition? A working definition for now is a coincidence, is a set of concurrent events perceived as surprising and meaningfully related with no apparent causal connection. That's some kind of working definition. And of course, I'm a mathematician, and there are a lot of weasel words on that slide. Perceived as surprising, meaningfully related, no apparent causal connection. It's hard to make math sense out of coincidences, but that's what most of us mean by coincidences, and it'll serve us for now. Just so that you know where I'm heading, I think. So I'm first going to talk a little bit about the history of coincidences. People have been thinking about coincidences and moved by them. Aristotle wrote wonderfully about coincidences. I'll tell you a little bit about Carl Jung and Freud. Then I'm going to talk about some tools that when you get fired at, as I do all the time. People are always sending me their funny stories. And what are the first 10 things I think about to try to make sense out of it? So I'm going to talk about some tools. Then I'm going to tell you some stories about what it's like to be on the forefront, actually doing it instead of talking about it. Right? That's different. Those are two different things. And then I'll try to draw some conclusions. So that's what's coming. Okay, so to start, not at the beginning, but a reasonable place to start is, so Carl Jung, psychotherapist, wrote a book called Synchronicity, and the subtitle was an acausal connecting principle, whatever that could mean. It's interesting for many reasons. It's still in print forever, for a very, very long time, maybe even now. It was the best-selling book that Princeton University Press ever published, and I was told that the income from it supported all the books we know about and care about that the press puts out. This was a book about coincidences, and what was it about? Well, roughly, he said, we all acknowledge that weird things happen. Weird things happen, okay? And he had a bunch of informal evidence, and I'm going to tell you some of it in a second so that you know what I mean. But the first, third of the book is stories. But at the time he was writing in the 1950s, there was a real perception that our naive understanding of the way the world worked was different. And he talked about the new physics and relativity and quantum mechanics and the uncertainty principle. He also included in the new physics astrology and parapsychology. Okay, he can have those, but and his understanding of relativity was at the level of, well, everything's relative, okay, and it was embarrassing. That part was embarrassing, but there was a perception that our naive mechanistic understanding of the world had changed, and at the time he was writing, there was some hope that there would be a science of parapsychology. It didn't work out, but what can I say? So he was saying, based on that, he introduced an acausal connecting principle. Okay, now let me tell you a story. This is one of many of the stories in the beginning of his book. I'll just read it out loud. You can too. There are, however, incidents whose chancefulness seem open to doubt. To mention but one example out of many, I noticed the following on April 1st, 1949. Today is Friday. We have fish for lunch. Somebody happens to mention the custom of making an April fish of someone. In Europe, instead of April Fools, there's April fish. Okay, and it's like an April Fool's, but April fish. That same morning, I made a note of an inscription which read, "A homo totus medius Pisces ab immo." Now, I have no Latin whatsoever, but Pisces is fish. Okay. In the afternoon, a former patient of mine, whom I had not seen for months, showed me some extremely impressive pictures of fish which she had painted in the meantime. In the evening, I was shown a piece of embroidery with fish-like sea monsters in it. On the morning of April 2nd, another patient whom I had not seen for many years told me a dream in which she stood at the shore of a lake and saw a large fish that swam straight towards her and landed at her feet. I was at this time engaged on a study of the fish symbol in history, you know, the one on bumper stickers. Only one of the persons mentioned here knew anything about it. So that's one of Jung's examples of a surprising coincidence, that he was moved by it and kept notes and you know, just thought something weird was going on. And so what does Mr. Wise Guy have to say about that? Okay, so here it comes. So in my part of the world, we have something, we have a notion of a random sequence with a given frequency. So suppose, I hope this makes sense to everybody, that you encounter the image or the word or to eat fish about once a day. Okay, let's just, you could change the numbers, but let's just suppose, you know, not frequent, not infrequent, and our notion of a Poisson process, sorry about that, but here's the timeline, and about once a day, you know, an image of fish. Of course, you can go a couple of days without, and then maybe three within a day, and so about once a day, an image of fish comes up. And what are the chances of observing what Jung saw? So let me make that into a math statement. Suppose you take a window of 24 hours. He went into the next day. So take a window of 24 hours and run it along that timeline. I took 6 months, okay? What are the odds that you see 6 or more blips in your window, you know, within a 24-hour period? Now that's a math problem. I've cleaned this up, made it into a math problem, and I like it because it's not so easy to do because of the overlapping and not disjoint time intervals. But you can do the math, and we like doing things like that. And the chances, I didn't want to do that, but I can go backwards. And we can do the math, and the chances, you know, about 1 in 5. It's not in any way surprising, 22% of having six events if they occur once a day. So a real question is, why was Jung surprised by that? Why was he moved by it, and what's it doing as a lead example in his book? With Fred Mosteller, when we were working on this, we took all of the informal examples and we subjected them to the same kind of, you know, crude first pass mathematical modeling, and none of them were surprising. That is, it was all, you know, and I don't want to make fun of Jung. Somebody asked him, you know, do you believe in this stuff? And he laughed and he said, what does it matter? My patients believe in it. So that's one of the reasons he studied it. I studied it. So his book is called Synchronicity, and some of you, the older ones in the audience, may know that that's the name of a Police album. And there's a marvelous song singing Synchronicity. I must have listened to that 20 times trying to get a good line for this talk, but I didn't really manage. Okay, so you can make kind of, you know, just analyses of things like that, and it didn't come out to be so surprising. Okay, here's the tools part of it. So many people will know this, but it'll go directions I think you might not know. So a thing I still find viscerally surprising, even as much as I know about it, maybe more than anybody, which is if you have 23 people in a group, like here, these two rows, right? Two of you have the same birthday. That surprises people. It surprises me inside. I mean, intellectually, I understand. But if you have a group of 23 people, it's even odds, 50-50, that two of you have the same birthday. And so people are surprised by that. We use it all the time in our teaching. And why is it surprising? Well, sometimes you might think people confuse it with what's called the birth mate problem. First of all, somebody says birthday. Well, okay, 1 in 365, right? So maybe, to have two with the same birthday, maybe it should be 183 over 2. I don't know. I mean, I do know, but I mean, people think that way. That is, 23 seems very, very small compared to how many birthdays there are. Sometimes they confuse it with what's called the birth mate problem, which is how many people do I have to meet to have even odds that somebody has the same birthday as I do? Okay, that's a different question. And it's more. It's actually a lot more. It's 253 in order to have a good chance. Why is it that big? Because only 365 birthdays. Well, when you're looking at these people, because of the birthday problem, some of them have matching birthdays. And you're not getting a random, fresh sample. Why is the birthday problem true? I mean, we can do the calculation, but what's behind it? Well, when January 31st, right? Here's 10 people, right? The two people that matched, okay, that's great, they matched. They could have matched any of the other people. That is this, I am doing that badly, but I'll get it better. There we are. This person could have matched this person or that person. There are many, many possible matches, and that's not a thing we're hardwired to see. That is, you and you, or you and you, and so each person could have matched with any of the other people there. And if you take 23 people and ask how many possible pairs are there, well, it's 23 times 22 over 2, which is 253, which is just what you need to get a match. So the psychology of what makes the birthday problem surprising is that we don't think of all of the different things that could have caused coincidences. Okay, that's the vanilla flavored birthday problem. Okay, now let's make a tool out of it. So the first thing is, let me get rid of birthdays. Let me have C categories. So for example, I claim that second hands on watches are useless. Probably everybody agrees with that. That is, suppose people still had watches with second hands, and there are 60 possible seconds. And how many people do we need to, if I say, now look at your watch, to have two people with the second hand on the same number? That would be a birthday problem with 60 categories. Okay, so I'm going to make C categories. Okay, and by doing a little easy math, and I decided not to put it on the slide because this is a talk for the public, but it's the kind of thing we really do teach in freshman probability. By doing a little easy math, you can see that if you have C categories, then a little more than the square root of C, 1.2 times the square root of C, that's how many people you need to have even odds of a match. So for example, if C is 365 for birthdays, 1.2 times the square root of 365 is 22.9. So okay, let's round that up to 23. That's fine. If C were 10,000, if somehow we had many, many categories, well, 1.2 times the square root of 10,000 is still only 120. One point, if you want to know, that's to have even odds of having a match. If you want to know what's the chance that you have 95% of a match, well, you replace 1.2 by 1.6. And for example, for birthdays, that's about 48 people. You need to be pretty sure that you have a match. And with 10,000 possibilities, that's this 160. So firstly, we've relaxed. We've gotten the birthday problem at least, with a general number of categories. Okay, now what counts as a coincidence? Of course, if two people have a birthday on the same day, yeah, that's surprising. Well, how many people do you need to have in a group to have two people have a birthday within a day of each other? Just relax it a little bit, within a day. And it's 14. It's hard to have a feeling for where that number comes from, but it's 14. And within a week, it's 7. So if you have 7 people around the dining room table, it's even odds that 2 of them have a birthday within a week of each other. Try it. Try it. Many categories. So there you are on a plane, and you're talking to the person next to you, and I just heard a talk about the birthday problem. Or where did your kid grow up? Where did you go to school? There are many, many different ways in which you could have a match. Suppose you have K different categories, and what's the chance that you have a match in at least one of them? Because then you just can talk about that, right? Oh, how surprising. I mean, forget about the ones that didn't work out. And it's this funny version of the harmonic mean, 1.2 times the square root of 1 over C1, 1 over CK. That's not so easy to parse, so let's do an example. So for birthdays, suppose birthdays have 365 categories. Lottery number, that is how many people, supposing this version of the lottery, that people pick a number between 1 and 1,000. So lottery number, how many people do you have to have even odds that 2 of them pick the same lottery number? And first name, I suppose there are 500 first names in common. You can change the numbers. There's a formula. You can do what you want with it. And here's how it works out. With birthdays, we know that you have even odds of having a match with 23. Lottery, 1 in 1,000 possibilities, you need 38 people. And with first names, with 27, if you know 27 people, it's even odds that 2 of them have the same first name. But if you count a match, if either birthday or lottery match, you get it's 20. And with 3 categories, with 16 people, you have a 50-50 chance of having a match. So having many, obviously, but having many different possibilities for having a match, drastically increases the chance of having a match, or you need many fewer cases. So that's many category. Here's one that's hard to think about, but I'll tell you about it anyway. So with 23 people, it's even odds that you have two with the same birthday. How many people do you need to have in a group to have even odds that you have 3 of them? Do we have 3 people in this room? Yes, I promise you. Let's not do it, but I promise you we have 3 people in this room with the same birthday. That's not a math problem for children, turns out. I mean, it might be. The birthday problem itself is very easy, but even triple matches. In the first day of my probability course, I ask people the question, how many people do you need to have even odds to have a triple birthday? And I say, I'll give $10 to anybody who can do it. And once every 5 years, somebody manages or something. And that's graduate students in probability. Here are the numbers. To have a double, 2 people at match takes 23 people. To have a triple match, it's even odds with 88 people. 4 people is 187, and 10 people, well, that's 10 people, all of whom have the same birthday. It's 1181. Just to show that we can do the math, this won't help you very much, but or it might, I don't know. Suppose I have C categories. not 365, but a general C, and I want a k-tuple match, and I want the chance of failing to be p, like 5% or something like that. How large does n have to be? And it's this funny formula. So let me just illustrate that formula by a story. I have a friend who came up to me and said, all right, Mr. Wise Guy, you know, my birthday, my daughter's birthday, and my husband's birthday are all on the same day of the month. What are the odds of that? And well, it's a triple coincidence with 30 categories. I just plug it into my formula, and if you know the day of the month with 18 people, it's even odds that 3 of them are born on the same day of the month. It's something you're not hardwired to relate to. It's a surprising, viscerally surprising how little will get you that kind of thing. But you can figure it out, and we do. And okay, so there are many, many versions of the birthday problem, and you may think, God, does it keep going? It keeps going. I'll give you a reference if you want to look this up and see the arguments later. But so the birthday problem is a useful tool, and we use it. We use it all the time. Let me try to abstract this or generalize it a little bit. So remember our definition, working definition, a coincidence was we had 2 or more events that seemed surprising and unusually close together in some essential aspects and yet have no causal link apparent. That was our definition of coincidence. Well, I have this idea, I think we can all share it, that we have something called perceptual space. How I'm going to make that precise, good luck to me, right? But we have something called perceptual space. Sure we do, all the things we keep track of. And suppose we see points as they occur to us day in and day out in our perceptual space. There's my picture of our perceptual space, and I've given them coordinates. That is, what time did it happen? Where did it happen? The name. There are different aspects of life as we see it. So different snapshots can be thought of as points in perceptual space. And I acknowledge that that's vague, and how many points do we need so that 2 or more of them are exceptionally close together? Suppose I have a notion of distance between 2 points. It's what we call a metric space. And so that's the general version of the birthday problem. And if you want to see that written out with words and music, it's a paper I wrote just recently, and the question is, when is a new point suspiciously close to an established corpus? And this could be DNA sequences in a database, or musical melodies, and think about plagiarism detection, scientific papers, that is something so similar to something that came before that is maybe plagiarized, stranger in town, or a murder mystery plot. Suppose somebody comes up with a new murder mystery plot and you say, yeah, well, okay. So you can take that picture and some of the math that I was talking about and get numerical answers that are useful in these problems. And if you wanted to see that, so this is a math sales pitch, and that's all I'm going to do about it. See a paper I wrote with Sharif Chatterjee and Susan Holmes, estimating the size of a set using cascading exclusion. And we make sense of how do you tell if you have a sample of random points in a high-dimensional metric space, how close should 2 of them be together, or when should you be able to raise a red flag? So I can make math of that. I'm not going to do it. I'm not going to do it here. So that's a tool, the birthday problem, and I do find it useful day in and day out. Okay, so I'm going to go back now, and what I'm going to do now for a few minutes is to tell you a story. Okay, and so I taught at Harvard for 15 years, and one day I got asked by the faculty in the psychology department if I would come along and help them evaluate, look at, experience an unusual psychic. And these were smart senior faculty in the Harvard psychology department, and I was asked both as a statistician and as a magician to come and watch. So there I am riding up in the elevator of William James Hall, top of the building, and you think, well, what's going to happen? What are these? What does it mean a psychic and is going to perform, and what's going to tell us about his deja vus? I don't know. And so I come in there are a bunch of graduate students, maybe 20 people, 30 people of that order, and there's a young man, long-haired young man, and he's definitely not introduced by name. He's just his initials, BD, and that's what I'm going to call him here. And I'm relieved to see that there are decks of cards scattered all around, so at least there's going to be something you can relate to, right? And BD did experiments that are kind of coincidence related, and I'll try to abstract what we can from those experiments, but let me tell you one of them. He had two decks of cards, a red deck and a blue deck, and he handed the red deck to somebody and handed the blue deck to somebody. He said, shuffle them up and put them on the table. He said, I don't want to touch them. You don't want to have anything to do with it. Don't think anything tricky is going on. And he said, would two people name cards? And somebody said the 4 of hearts, and somebody else said the 6 of spades. And he said, great. And he said, the cards have been shuffled and I haven't touched them, and those, you just named 2 cards. And he said, let's turn the cards over simultaneously. So turn over cards this way, okay? And wait until one of the 2 cards came up, and the 4 of spades came up here. And he said, 14, 14. And then they counted down 14 cards in the other deck, and there was the 6 of hearts. And it would just seem pretty surprising. And now, he did lots of things like that, and they weren't tricks and things often worked. When they didn't work, the audience was sympathetic. Well, he can't be a trickster because otherwise it would always work. Okay. So I noticed that, and you may notice that BD didn't specify what was going to happen before the experiment started. So let's just think about that. Suppose there are the 2 decks out, 6 of hearts, 4 of spades. Suppose the top cards of both decks were the 4 of spades. That's pretty surprising. Stop, right? Okay. Suppose they'd both been the 6 of hearts. Stop. One could have been the 6 of hearts, one could have been the 4 of spades, or 4 of spades, 6 of hearts. None of those happened, okay? So now count down until, turn over simultaneously until one of the cards comes over. If this card had been the 6 of hearts and that's the 4 of spades, that's great. That's very amazing. Could have been 2 4 of spades, 2 6 of hearts, 6 4 4 6. None of those things happened. So he said 14. He didn't say I'm going to say a number, but he said 14. And then count down 14 cards, and then it could have been, if this was the 6 of hearts, it could have been that this was the other 6 of hearts. It's a red deck and a blue deck. So there are a lot of things that could have happened. And by the way, if it hadn't been on 14, turn over the next card. Right? So another possible match. And if you just take those possibilities into account, the chance of a successful occurrence is about 1 in 8. It's not very surprising. It's just, you can try it on the computer, you can try it with your friends, or, pretend to print that. And what if instead of it being the 6 of hearts, it had been the 6 of diamonds? I guess it happened. He said, I'm really having a hard time seeing the suits. So BD's performance went on that way for a couple of hours, actually, and his things worked about 1 in 8. They didn't, and the fact that they failed made everybody believe in him more, as it were. And I have to say this part of it. So at some stage, I'm watching like a hawk, And at some stage, I see him look at the bottom card of the deck. That's the 4 of clubs, okay? But I'm sitting behind him, and he's like a kid, you know. And then he cuts the card so that the 4 of clubs is in the middle of the deck, but he leaves a step, not subtle, you know, an inch. Right? And then he spreads the cards out on the table, and he had somebody touch a card, and he had them put it back, and suppose the card they chose was the ace of spades. So he spotted the 4 of clubs at the bottom, and then I see him count, again like a kid, how many cards are in between the card that was selected and that original bottom card, and there were 7 of them, okay? And then he puts them back together and backs away from the deck. I don't want to touch the cards now. And he said, now you're thinking of a card. And it wasn't you're thinking of a card. You picked a card and you put it back, okay? And he said, we need another card. Oh, say the 4 of clubs. And he named the card he spotted originally. And then he said, now, and he got way away from the card. Said, you know, he said, now start turning them over until one of the 2 cards comes up. And so the 4 of clubs came up. And he said, we need a small number. And somebody said 2. We need another small number. And he eventually got 6. And so you could count down 6. And then, you know, this. So he took dead aim. I mean, he said, I think this is really going to work this time. And I did too. And so some of the time he used a little sleight of hand. But at the end of the day, I rode out of down the elevator with the other faculty, and, you know, what do you think of it? And some people were aware that, you know, it was chancy, but the overall effect was that something really strange and inexplicable happened. And I noticed that they did the following. They confounded, you know, some of the times he never touched the cards. Those are the times in which it worked 1 in 8. Other times he said, it's going to work, but those are the times he did a little sleight of hand. But they confounded those things together and it's hard to keep track of it after a couple of hours. And just so that, you know, for what it's worth, Science magazine announced about 6 months later that Harvard University had awarded BD, you know, $100,000 for a year research contract. So that people were moved by the performance in ways that are surprising if I tell you about it that way. But of course, that wasn't the way it unveiled. So that's a typical. There are many tales of that type. So let me abstract a little bit about that for our purposes. What are some lessons to be learned from the story I just told you? Well, one which we've seen before is the cost of multiplicity. That is, if you have many different things, any one of which can count as surprising. And if just one of them happens, well, gee, you know, so you have to pay for that, right? Some way you should have to pay for that. But so the problem of multiplicity, subject cheating. Now, in this case, there was no question. I mean, I'm a professional magician. I know sleight of hand when I saw it. But let me abstract a little bit. So we all get told a lot of stories. You know, the damnedest thing happened. People like to tell a good story. And they clean stuff up. They say it happened to them and it happened to their sister. They say it happened last week and it happened 5 years ago. And they just lie. I mean, you know, to some extent, it's not careful reportage. However, how much do people lie? We don't know. And I looked pretty hard. I mean, I studied the literature. It's not that there's no literature about lying, but it's awful. Sorry, it's every place. We all know that. Well, yes, of course. It's even on TV all the time. But how much do people lie? And there's very poor quantification and understanding of it. It's kind of black boxish. But that's one of the problems that confronts you if you try to evaluate what are the odds of that. Right? If somebody changed the story and made it sound better. Here's another one which is very important causer of coincidence. I call it the bundle of sticks phenomena. When people were trying to evaluate whether BD was real or not, they conflated the times when he wasn't cheating with the times when he took chances, and the images of many broken sticks. But the psychologically, the bundle has a strength that no one, each performance, each item he did was phony or unexplainable, easily explainable. But the collection of them has a strength, and of course that's an old image in a Kurosawa movie. Warrior gives each son an arrow and they break it, but then he gives them a bundle of arrows and you can't break them, right? So we think that way, and so that's a thing that this is a good example. So if you want to see this story written out, I'm not just making it up to tell you. I was moved enough by it to write it down. It's an article I wrote years ago called "Statistical Problems in ESP," and it documents many things that I'm not telling you about. But yes, okay. So that's okay. Towards a rational theory. So how should we think about perceived coincidences? And I have a few rules from thinking about it for many years, and one key thing is, of course, there could be hidden cause, and that's one of the reasons we're moved by coincidences is what we do in science. When Jocelyn Bell noticed peaks in her signal, and her advisor said, "Oh, you just don't know, those are the fluctuations of electricity." And she didn't listen to him, and she kept following it up, and she discovered pulsars. That is, periodicities, regularities, are signs of a hidden signal that we don't know. So there could be a hidden cause. Of course, there could be a hidden cause. It's people cheat too. That's another hidden cause. And this thing I told you about, is it true? That is, or did somebody make it up? This Lisa Belkin, who wrote the New York Times report, did due diligence, and she went and reviewed the 10 cases of scientists who were killed, and 6 of them or so. Well, it wasn't really a scientist. It wasn't working on bioterrorism, and the details were, what was in the newspaper was different than the truth. How surprising. Okay, multiple endpoints. If many different things could count as surprising, then you have to charge yourself for that, or try to think about charging yourself for that, at least psychologically. Several times I've talked about the cost of close. If you give yourself credit for a match when they're within a day, or within 3 days or something, or if they're the 6 of hearts and the 6 of diamonds where they should really match, well, it's much easier to have something surprising if you give yourself credit for things that are close. Here's one that is a huge causer of coincidences, maybe one of the main ones, and I call it the law of truly large numbers. And the law of truly large numbers says if you have enough chances, any damn thing is likely to happen. Okay, now, what do I mean by that? Well, Littlewood, a wonderful mathematician who wrote about coincidences, said something should only count as surprising or a coincidence, if it's chance 1 in a million. Well, I don't know, there are 400 million people in the United States, so we should expect, if we were looking, to have 400 1 in a million shots every day, right? And if that happens to you, you don't just let it happen. You put it in the newspaper, you tell people about it, it gets broadcast. And all the ones that don't work don't, well, they just, okay. It has a cost talking this way. I have friends who will call me and say, today's my birthday. Oh, happy birthday, Brad. And I ordered a new Honda. I said, oh, and he said, and I was sure it was going to come today, and it didn't. Okay. So, but if you have enough chances, any damn thing is likely to happen. So here's an example. It was in all the papers that a woman bought a lottery ticket and won the lottery, big lottery, and then the next week she won the lottery again. And that seems That seems pretty unlikely. And the number that was reported is 1 in a trillion, and that's bigger than 1 in a million. Now that's the right answer to a funny question. The question that's the right answer to is, what if she bought a ticket in the lottery and bought another ticket, and that's all that happened, right? What are the chances 1 week in a row? Now, this woman bought multiple tickets in many, many states over months and months and months. And not only this woman did that, thousands of people, millions of people buy lottery tickets, right? And if it ever once happened that 2 of them, won lottery 1 week after another, that'll be in the newspaper, right? So that's an example of the law of truly large numbers. If you do the math, the chance that you get a double lottery winner is about 1 in 30 in a 4-month period in the U.S. So again, it's not surprising, even though it's shocking when you first hear about it. So that's an example but okay. Now, if I wanted to proselytize for something, I could say, I am going to tell you there is such a thing as synchronicity. There is a hidden force that's not causal and not chance, and here it comes. Okay. Coincidences occur in the mind of an observer. And so the punchline there is, again and again, we've seen that things, when people report this amazing thing, when you look at them, they're not so surprising. Why are people so surprised by them? So the psychology of perception has to be an important ingredient in evaluating how surprising something is. And some buzzwords about this are memory failure. That is, we remember the things that happened and don't remember the things that didn't happen. They're also called numerator-only problems. Right? We don't remember what the denominator is, just the things that happen. Selective awareness. So there is a phenomena called the cocktail party phenomena, in which you're at a loud cocktail party, like what was going on outside, and you can't hear anything. But if somebody says your name, react, right? It's very well documented. We perceive all kinds of things that we're not aware of. We're tracking things. We're aware of all kinds of things, and we don't remember the things that don't happen. And when that happens, well, we notice it. There are psychologists who work on psychology of coincidences, and one of the interesting findings was Ruma Falk's, which she asks people, how surprising is this in series of experiments, and people find things that happen to them much more surprising than the same thing that happened to other people. We all do that, so let's not make fun of anybody, but mine versus yours. Here's one. So now let me own up. I'm about to say BS is maybe the wrong word, but anyway, hardwiring. So I can't make science out of this, but I believe it's true. Maybe somebody here has an idea how to make science out of it. Imagine primitive man in the jungle, okay? And look in the bush. It kind of looks like stripes. And maybe you just better get out of there and not figure out the odds that it's a tiger, right? So we're hardwired, I want to say, that's a bad word. It's an unscientific phrase. But we're hardwired, I just said it again, we're hardwired to react to patterns around us. Of course we are. And we're not even aware of that. And whatever mechanism for staying alive, we're hardwired to notice patterns around us. Whatever mechanism is there, if it was developed, a million years ago, and the ambient world has so much more, so many more signals coming in. There are zillions of chances of having surprising things matching. So I wish I could make scientific sense of that. I know I can't, but the psychology of coincidences is perhaps the main causer of surprising coincidences. So suppose you wanted to look up some of the things I said or see references. This talk, soon to be a major motion picture, is written down. I wrote a paper with Fred Mosteller called Methods for Studying Coincidences, and there are many, many stories I haven't been able to tell you. And Susan Holmes and Fred and I are writing a book in coincidences and statistics, and it says any day now. I wouldn't hold my breath, but we're really planning to do it. It has a lot of stuff I haven't been able to tell you about. I'm glad I had a chance to tell you about the things I did tell you about. Thank you.
Thank you very much, Persi, for a wonderful lecture. Any questions? Let's see that. So far.
Have you applied your ideas to UFOs?
Yeah, that is complicated, you know. I'm pretty much a skeptic, and let me at least put this on record. I have been, because of my magic background originally, but also now as a statistician and somebody who's known as, you know, I'll listen to anybody. I've been trying to track down things that are at variance with science for, 50 years. And at least in the kind of parapsychology, scientific investigation of weird things, I've looked and spent weeks and months, and I never once did anything happen that was surprising. I haven't done UFOs personally. I have a friend who spent a year coordinating reports of UFOs in New York State, actually. And he was a skeptical guy too, but he just thought it was interesting. And what he said to me is, he said, I never saw a smoking gun. He said there were, mostly when there were reports, it was, the Air Force was flying some funny plane over, and then there were multiple sightings. But he said, there were things I couldn't explain, and I don't have an expertise in that domain. And many things are possible, but I do talk to people who talk that way, and I try to follow up, and I never saw anything. I said, yes, wouldn't take much, right, to find some evidence that we said, yeah, somebody could have me shuffle the cards and call out every card. That would only happen to happen. Somebody could really break the physical law. So, but it's still try to keep.
Yeah, you mentioned Jung. Why was he interested in these questions? And you also mentioned Freud. I didn't hear anything about it. What's the difference between these two in this context?
Thank you. I didn't. Thank you for reminding me that I forgot to tell. So, Jung was spent, hundreds and hundreds of pages talking about coincidences, and one of the main websites that chronicles coincidences is Modern Jungian. So but let me say something about Freud. So Freud gets bad press, and I'm as skeptical as him as anybody else, but he was also a pretty smart, interesting guy. And I'll tell you a story that Freud writes about. He was sitting in his office, he was in his 40s, and all of a sudden, for no reason, he thought of a friend that he'd gone to high school with 25 years ago, and he hadn't heard from him, or thought about him, and he had no reason to think about it that he could see. And then in a few minutes, his assistant knocked on the door and said, Dr. Freud, there's somebody here who doesn't have an appointment, but he says you know him. And it was the friend. And Freud was just flabbergasted, because it was a kind of coincidence of the kind that moves us. But then he was bothered by it, and he began to think about it. And as he writes, he said, I remembered that the friend had an accident, and he walked with a cane, and he had a very distinctive tap, 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 tap. And he said, I must have been sitting in my office, the door open, and I heard that tap, tap, tap outside as he was approaching the office. And then he came and it reminded me, and so he was a clever, interesting guy. He wrote about coincidences quite a lot, and if you look at my paper with Fred, we chronicle some of he had very interesting stories, and you read it and you say, okay, he was a pretty smart guy. That's it. Whatever I think about.
So I'm curious how you personally feel about coincidences, and if you think that synchronicity is real, given all of the studies that you have.
My skepticism, how do I think about coincidences? Well, I've had very, very strange things happen to me. To tell one of them, it's about a minute story, but I'm going to tell it that coincidence. So when I was 20 or something like that, I got a letter. I was an on-the-road magician, but I got a letter saying I'd been inducted into the Army. One thing I didn't want to do was go into the Army, doing magic shows and traveling around the country, chasing showgirls and so on. But you break the law, you're going to pay for it. So I showed up, and I had a story about I have bad dreams, and I this or that. So I fill out the forms the right way, so that I get to see the psychologist. And I'm sitting on the bench, and there's the guy dressed in girl's clothes with full makeup, and he goes in ahead of me, and I can hear the doors open, and I'm just quoting. Please don't take offense. I'm just quoting, and the psychologist says, "Oh, so you're a fag, huh? Boom! The Army will make a man out of you. Out next. My turn, right?" So I go in, and he says, and he says, "Wait a second, you have a mother who's in and out of institutions?" I said, "Yeah." He said, "You have a sister who's in institutions?" I said, "Yeah." He said, "I'm her doctor." And he said, so that happened just the way I'm telling it to you. And he said, "You're filling out the wrong thing. Let's rewrite this." And he changed my entries a little bit. So, and then I was out in 4 hours. And so, that's some strange things happen, right? That happened to me. What are the odds of that? I don't know. But very, very often, perceived coincidences can be explained, and we all look for, scientists, we look for patterns all the time. Mathematicians, physicists, all of us. We look at data and we hope to see a pattern, but we can be fooled by noise and off and on. So I'm skeptical, but weird things happen.
One more question here.
Yeah, so here's the question. Again, it's a question, and I don't. It's based on what I think, because coincidences, I believe, are important in propagating religious doctrines, and I would imagine the theological scientists, whatever that is, study coincidences because the explanation would be divine, and I would imagine that there should be an army of theological scientists studying these, trying to prove, otherwise, that the explanation is divine rather than mathematical. So the question is, do you sort of have any contact with that field of work?
So I hope people understood the question. Very clear, interesting question, and the answer is no, and I should. I've had a hard time accessing the academic ecclesiastical literature. I've tried, because of my interest in magic tricks and deception. I've gone to the Vatican Library and had help, but I'd need some scholarly Jesuit to help guide me through a labyrinth of things. But you're right, there must be interesting literature that comes out of the church about coincidences. The Talmud, the early Jewish literature, has pretty interesting probability calculations trying to quantify whether something should qualify as a miracle. And there's an interesting book called Probability in the Talmud, which I won't digress on, but Menachem L. Rabinowitz. So this curious, way before in the Talmud, so 200 AD. So I'm sure that there's good stuff there, and I just haven't done the work, but I have a book to study for, so good. Thank you. It's a good idea.
One last question here.
Yeah, you mentioned Jung, and I I somewhat surprised you never mentioned Pauli, and I know they worked a lot, like exactly on that thing. And I have to say that, I mean, as physicist, maybe it's a little bit biased. I think there is like a tendency among theoretical physicists to actually go into something fairly fringe. There are almost
You said it, not me.
mainstream ideas of importance of quantum mechanics for intelligence and things like that. So they are like very unlike someone who
It's always debunking everything.
yes, exactly. So what is your perception of like role of physicists in propagating those concepts?
Well, there have been, I mean, you know, it's a very broad question. So let me help people join us in the thinking about it. So Wolfgang Pauli is, you know, Pauli exclusion, the great Pauli, and a wonderful, wonderful physicist. And he, it turns out that one of Jung's books is analysis of dreams, very detailed analysis of dreams, and they're very telling and very incriminating, I don't know, personal, and it was Pauli. Pauli was analyzed by Jung, and Pauli and Jung had a intense relationship. So Pauli was one of the smartest people that we've had, didn't, you know, see through Jung or find him foolish, and found him clever and interesting and useful to him. Now, you know, if I get to record the best of physics, it's just wonderful. If I get to record the worst of physics, boy, you have some pretty funny characters around. I mean, it's a different talk, but in the article that I wrote in Science, I talk about my catching a psychic who made psychic photographs with his mind, like catching him cheating, and that was brought to me and brought to Scientific American by a group of physicists and who believed in him and wrote books and were taken in by him. I have written at length about Uri Geller, who was an Israeli psychic who does sleight of hand, but who was very carefully vetted and sold to the scientific community by scientists at SRI and physicists at SRI, Albutoff and Targ, laser physicist. And so, you know, the worst is embarrassing. The best is you guys are the best, and I'm happy to look at the best side of it.
Okay, well, I think we can close with this note. Thank you very much for a wonderful lecture.
Thank you.